Hello, pre-calculus classes. This is Mr. McAllen, and today we're on day 11 of our flipped classroom, and we're going to talk today about how to use trigonometry to find things that could seem immeasurable. What we have here is a picture of Mount Everest. It's known to be, at least I think this is Mount Everest. It's known to be 29,000 feet tall, roughly about 5.5 miles, which is, you know, I think it's the highest mountain peak in the world. And how did they ever measure it or know how tall it was without physically getting to the top and using typical measuring instruments? Well, they used trigonometry. And one approach that could have been done is what we're going to go over today. So what I'd like you to do is I'm going to pause the video, and you should copy this into your notebooks, and then we're going to draw up a picture that represents this. This is probably going to be one of the most involved trigonometric problems that we work on. So that's why I want you to have a copy of this in your notebooks. And also, I'd like you to watch this video and have it to reference in the future. So I'm just going to pause the video, and you should be copying down this problem. Okay? Okay. So what you should have copied down, or you should be familiar with, is it's two measurements were made of the mountaintop. So this is like the mountain, and two measurements were made from a distance away from the mountaintop, and the measurements were made such that they were trying to find the height of the mountain. So the first measurement was made at a distance that we really don't know, because we don't know what the distance to underneath the mountain was, and we're going to label that to be x. Okay. The next, the angle of elevation. Well, the problem says here that the measurement was made, it was 49 degrees, the angle of elevation. The surveyor then drove. That's 49 degrees. The surveyor then drove 5 miles away. So they drove 5 miles away. Hopefully they're still on level ground, and we're going to make that assumption. So now this distance here is 5 miles, and they measured another angle of elevation to be 29.43 degrees. So this is called a double triangle problem or approach, and we're going to actually make up two trig triangles. So the first triangle is the one that is the most basic. It's got x, it's got h, the right angle, and 49 degrees. The other triangle is one that is combined with the one we just drew, but we're going to draw the outermost triangle, and I'll draw that in red, and that will be this one right here, the bigger of the two. And that one has similar dimensions. It has the height of the mountain, but this dimension here is not 5, it's not x, it's 5 plus x to the base of the triangle. And the angle here is 29.43 degrees. So in this approach, we're going to have two trigonometric ratios. The first one uses a tangent ratio. So I'll just do that in black ink so you can follow along. So I'll draw in black ink, and I'm going to write a tangent of 49 degrees is equal to h over x. The other one uses, I'll write this in red ink just to be consistent, uses also the tangent ratio, but of 29.43 degrees, and that ratio is going to equal h over 5 plus x. So we have two equations and two unknowns, two independent equations. So I can solve for either h or x, and then plug that into the other equation, and then solve that equation for either h or x or whatever's left. So what I think is the easiest thing for me to do is to solve for, I'm going to solve for h, and because all I have to do in this equation is cross multiply the x over. And now I know that h is equal to, and I can find out the decimal amount for that. So I'm going to just use my calculator, and I'm going to say, what is tan of 49? and it's 1.1503. So right here I have the amount of 1.1503 times x. So that's what h is. So I'm going to use that information and I'm going to plug it into this equation so that I could solve for x. And this is where it gets a little involved and you have to be a little bit careful with how you go about and solve this. So I'm going to just go to find some, I'll do my substitution in, I guess I'm going to use a different color ink. So I'll have tan of 29.43 is equal to 5 plus x, but the h that is on top is going to be the 1.1503x. So I have a ratio, and remember how we solve any ratio, we cross multiply. So I'm going to cross multiply the 5 plus x against the tangent of 29.43. That's going to equal the 1.1503x. And if you look carefully at this, I've got the tangent of 29.43, so I want to really find out what that decimal amount is. So the tangent of 29.43 is equal to 0.564. So this is 5 plus x times this amount here is 0.56416. So put the calculator away. I remember I could distribute that to both. So my equation is going to become a nice linear equation, and it's going to be 5 times 0.56416 plus 0.56416x equals 1.1503x. I'm going to multiply everything out just to get some nice, to get rid of these ugly decimal places. So I'm going to have 5 times 0.5614. Make sure you recognize, as I just want to make sure that I'm putting things in correctly. So that should be 5 times 0.564. So I've got to put a 4 here, 16. Hit equals, and that's going to be 2.8208 plus 0.56416x equals 1.1503x. The biggest mistake kids make with problems like this is when they're transferring information from the calculator to their screen or to their what they're writing down, they misrepresent or switch a decimal or a unit or some sort of a digit gets transferred. So be really careful with writing out these equations. So now I've got to we have a linear equation, so I've got to subtract that amount from both sides. So I'm going to just subtract 0.56416x from both sides. And what I'll have is 2.8208 is equal to, so now I've got to be really careful with this calculation, 1.1503 minus 0.56416, and I get 0.58. So here we get another ugly decimal, 58614, and that's x. So now to solve for what x is actually equal to, we divide 2.8208 by that decimal amount. So it would be 2.8208 divided by 0.58614, and x turns out to be 4.125, 8125 miles. Okay, let's take a look at our original problem. Our original problem, 4.812 miles. We now know that what x is, 4.8125 miles. So our goal was to find h though. We found x, and now we have to look back through our equations, and do we have any equations that relate the height of the mountain to the x value? And that's this equation right here. It's one of the ones we started with. So we're just going to take the answer that we had, and we're just going to plug it in. So the height is equal to 1.1503 right here times 4.8125. And that will tell us the height of the mountain, which is, calculator please, 1.1503 times 4.8125. Hit enter, and we get 5.535 miles. So we have just found that this surveyor, by his measurements, we can calculate the height of Mount Everest to be 5.535 miles. Hope this problem helps you understand how to use the double triangle to solve for a height of a mountain. Okay, so what I want you to do now on your own is I want you to set up for class the height of the water tower problem that I have displayed right here, because we're going to do something like this, similar to this in town. So this is your exit ticket. Well, this is your thing to complete. I want you to draw the two triangles and show the two trig ratios for the problem. Do not solve the problem. I'll ask in the Google form for you to report what your two triangles would be. So, for example, if you had, the one trig ratio is, tangent of 49 equals h over x, you would just type down tan 49 equals h divided by x. So what I want you to do is figure out your picture and then report those two trig ratios that we used, and have that done for the next day we meet, which would be Tuesday. Good luck, everybody.